Hey up, this is an updated workflow for working with point clouds in Blender, primarily for technical artists. For this tutorial, you will need a custom ply importer made by Microprostka. It will allow us to import colour data, as the built-in importer doesn't support this yet. However, there is a new importer for Blender currently being developed. It will allow us to import normal data. You can check on its progress on projects.blender.org, but until then we'll be using Michael's. To install this importer, you will need to download some files off his GitHub page for import ply as verts. Download the zip file and navigate to the Blender files folder. Import ply and init are the only files we need. Now navigate to your Blender directory, which will be normally found in C, Program Files, Blender Foundation, and then Blender 3 something. Then navigate inside the version number folder, Scripts, Add-ons, and then IO Mesh Ply. You will find the same import ply and init files that we just downloaded. We are going to replace them. You can rename the old versions to a different name or just delete them, which is a bit easier, and then copy in the new files. Now, once we reopen Blender, you will find under the import menu that we can use import Stanford ply as verts instead of just Stanford ply. You can now import a point cloud file of your choosing. Depending on the size, it may take some time. I would advise to start with something small. On my computer, something under 10 million points is quite performant. Now we've got the point cloud imported, it's going to be very difficult to tell what's going on at first. So, to help with that, we are going to convert the object type to a point cloud. This is only available in 3.5, so if you're running 3.4 or lower, use a geometry nodes modifier with a meshed points node. If you are running 3.5, you can just add the modifier and a set point radius node. I like to drag out that radius parameter into the modifier so I can control it externally. We can adjust the radius to quite a small value. If the value is too large and there are a lot of overlapping points, you may encounter lag. Now, you're out of colour just yet. You will need to make a new material that's assigned to our object and add an attribute node with the attribute name of col. Connect that node up with the principled BSDF. Go into rendered preview mode. Make sure you are using cycles, as this does not work on Eevee, and you should have working colour. If this doesn't work, you can check the name of the colour attribute in the Objects Data Properties tab. At this point, it's probably good to switch to an emission shader, as it will give us a more accurate view of the colours. First, check that the gamma is correct. Depending on the camera you use to make the point cloud, you may have to change this value. A gamma of 2.2 is usually what you need. Once you've finished your colour correction, you can switch back to the BSDF. You can now position the point cloud however you would like. If you don't need the modifier at this point, you can apply it to save some compute time. Add some lights, and there you go. This process can be repeated to import as many point clouds as you like, but I would suggest to wait until we have normal data being imported before creating a massive point cloud library. Some important considerations to make when designing your scene is that a point cloud can only support one material. The only way around this, from what I know, is to convert the object back to a mesh and separate it into different objects. Another limitation is if you want a shape other than a sphere, you will need to use an instance on points node. You will need a realize instance node to see the colour. We can use the set position node for explosions, distortions, and disintegration effects. More complex ideas like this point cloud morph effect can blend one point cloud into another. With the simulation nodes branch, many more effects can be achieved. I have a cell division simulation, where the most important simulation step uses a merge by distance and a geometry proximity node to give us a vector pointing from each point to an area of high local density. But the simulation nodes branch is also useful for simpler effects that need velocity information for more realistic movements. An overlooked use case would be using the points to volume node into a volume to mesh node. This allows us to meshify our point cloud. This is incredibly useful for point cloud environments. It allows you to fill in large areas. This can block light, helping the mood of the scene. You can also use this on smaller objects, where a more obvious silhouette is needed. Thanks for watching. Feel free to ask any questions about the process. Cheers.